Okay, so this is video 3 where we're talking about ternary ionic compounds, which means that they have 3 or more element symbols in the formula. Now, when you're looking at the name, you're going to be looking for a couple things. You're looking for compounds where the second name of the compound ends in ATE or ITE. And then we talked today in class about the 3 exceptions to those that are polyatomic ions that end in IDE, which would be peroxide, cyanide, and hydroxide. Those are the only 3 polyatomic ions we're going to be dealing with in class that end with IDE and are polyatomic ions. Anything else that ends in IDE, they are nonmetals. Okay, so what you're going to do on these for this is you are going to write down the metal, if it's a metal, its oxidation state, and then write down the polyatomic ion with the correct charge. So that's where you're going to use your sheet that had all the polyatomic ions, and they're in a column based on their oxidation number. So potassium is in column 1. It's on the periodic table in column 1, so you're going to put a K with a 1 positive. Hydroxide is OH, and it's in the -1 column. So then we're going back to those steps we've done in the other 2 videos, where if these 2 oxidation numbers are the same with opposite signs, they cancel each other out, and you just write all the symbols down. Okay, aluminum sulfate. Aluminum on the periodic table, it's in column 13, so it has a 3 positive charge. And then you have sulfate, which ends in ATE, which means that's my clue. I need to go back to that polyatomic ion chart to look it up. If you look it up, it's in the right-hand column, top section, it's in the 2 negative column, and it's SO4. Now be careful because there's a sulfite, which is SO3. So don't get confused when you're writing those down. Those are 2 different polyatomic ions. So you write SO4 down, 2 negative, and then you're going to check those oxidation numbers. Are they the same number with opposite signs? The answer is no, so that means we're going to have to crisscross. Now, you have to be careful when crisscrossing oxidation numbers to come up with these subscripts down here. I just covered up my work there. Okay, because when you crisscross oxidation numbers, like Al, 3 positive, SO4, 2 negative. When I bring that 2 down behind just an individual element, no big deal. I just write it behind it. But this SO4 is actually a group that are connected together. You can't separate them, and I cannot change that number right there. Okay, that has to stay the same. So, in order to protect that group, I have to put it behind some barriers, which are going to be parentheses. So that's going to be SO4 in parentheses, and then I'm going to bring that 3 behind the parentheses. So the only time you're not going to use parentheses around a polyatomic ion is like right here in the first problem where we had KOH. OH didn't need any other subscript besides 1 behind it, so I didn't need polyatomic ion. So if it's an understood 1 behind the polyatomic ion, you do not need the parentheses. So if that number had been a 2 or even a 10 or a 5 or something, you're going to need parentheses. Oops. But if it were a 1 coming down because that was a 1 positive, then you would not need the parentheses here. All right, so let's erase all this over here. All right. Let me move this picture over. Okay, so again, if you're crisscrossing and this number that goes here is a 1, no parentheses. Okay? If you're crisscrossing and there's a number that's greater than 1, you need the parentheses. Okay? Whoops. Keep hitting the wrong button. Okay, so aluminum sulfate. Aluminum sulfate. Aluminum is Al3. Oh, I just did that one. How about we don't do it again? All right, the next one, ammonium. Is that a metal name? No, that is one of the few cations that are positive that are positive polyatomic ion. So ammonium is actually a polyatomic ion. It is NH4. It has a 1 positive charge because it's in the first column. It's got 1 positive above it. And then it has hydroxide. And hydroxide is OH with a 1 negative. Again, this is a group, if it helps you to know that those are a group that you can't change anything within that box, put a box around it. Okay? So NH4 has a 1 positive, that has a 1 negative. That means that those are both going to cancel each other out. So all I have to do on this one is just write the formula down like that without any crisscrossing. So there's no crisscross needed on polyatomic ions if their oxidation numbers cancel out. Alright, the next one in this list is not done for you. It's gold to phosphate. Ooh, so you can have a transition metal with a polyatomic ion. So we just go back to the fact that that right there, that Roman numeral in gold, tells me the oxidation number for gold. So gold is AU, and it has a Roman numeral 2 after it, which means that this gets a 2 positive. And then the other part of the formula is phosphate. So phosphate ends in ATE. I'm going to have to look that up on the polyatomic ion sheet. You're just getting used to this, so it's on the right side of the page. It's in the 3 negative column, and there is a phosphite, so make sure you're looking at phosphate, which is PO4, and its oxidation number is 3 negative. That means it has 3 more electrons than what it actually should have if it were neutral. Now, this 2 positive, this 3 negative, they are opposite charges. Here's my polyatomic ion that I need to guard. So when I bring this 2 down, it goes back here behind the polyatomic ion, which means I need 2 of those groups that I just boxed in, and this is getting a 3. So AU gets the 3. It's an element by itself, so no parentheses around it, but my polyatomic ion, PO4 phosphate, needs that 2 behind it, so it has to go in parentheses. And anytime you see that, that means that what you really have here is AU3 PO4 PO4. You need 2 of those groups. Here's 1, here's 2. So that's where that little subscript 2 is coming from. But this is not the correct way of writing. This is not the correct way of writing that. Okay? So it's AU3 parentheses PO4 3. So the subscript behind a polyatomic ion, if it is greater than 1, the polyatomic ion has to be in parentheses. And I'm not talking about this subscript. I'm talking about this one that's coming down from an oxidation number. Okay, so just make sure you watch those. So this would be a 2 positive, and this is PO4, 3 negative, and then here is the answer that goes into that box. So tomorrow in class we'll practice these. Okay? So rewatch this if this doesn't make sense, and then we will practice some more. Make sure you fill in the boxes. Okay? Great. Thanks. Have a good evening.